When you rub your palms together fast, you'll notice that they get heated up, and we actually do this to get warm when we're feeling cold. This is because of friction, and the faster you rub your palms, the hotter they get. Basically, the higher the relative linear speed between your palms, the higher the heat generation. The same phenomenon occurs during metal cutting. The temperature rises as the cutting speed rises. The tool material is designed to work at a certain temperature range. Below this range, you are underutilizing the tool and the cycle time will be unnecessarily high. Above this range, the tool wear will be too high and you end up with high tool costs and high machine downtime to keep replacing the tool. High cutting speed and temperature also result in poor surface finish and unwanted metallurgical changes in the workpiece. Tool wear is the erosion of material from the tool. It changes the shape of the tool cutting edge, increases cutting forces, results in poorer accuracy and surface finish on the part. These are some types of tool wear. Flank wear, the picture in the middle, is the most common. As you can see, it makes the cutting edge more blunt, resulting in higher cutting forces and changes in part dimensions. Built-up edge is the deposition of workpiece material on the cutting edge of the tool. It is not actually tool wear, but its effects are the same as tool wear. The deposited workpiece material becomes the cutting edge. So the cutting forces become high and dimensional accuracy and surface finish are poor. This video shows built-up edge while turning an aluminum part. In the first cut, the surface finish is good because the cutting edge is new. In the second cut, built-up edge has formed, and you can see the poor surface finish as a result. Tool life is the cutting time for which the tool is usable. Usable means that the tool is giving you parts within tolerance limits with acceptable surface finish and without cutting forces and vibrations becoming too high. The end of tool life does not mean that the tool is actually broken. For example, you might have to change the cutting edge when the flank wear becomes a certain value.